Okay, so we're gonna be trying to actually do some code that can possibly control motors, and we'll also introduce how we split, separate, and organize code. And the main way that we organize code is through subsystems. So if you think about it, what kind of components are in a robot, right? What are some ideas you guys think might be involved in a robot? Like what kind of systems might a robot run? You guys can say it in chat or something. So when you guys think about like what kind of mechanisms or components that a robot might have, you can
Oh,
if you think about just about anything that like might show up in an FRC
okay,
game.
definitely motors because like everything
Okay.
has a drivetrain.
Right. Okay. So
So
you just said drivetrain, right?
maybe like some pneumatic components, like when like lifting ladders or stuff, or like shifting components.
Okay. So like a lifter. Samir, do you have any ideas of what a possible component might be?
I was thinking motors, but that's already
Yeah.
there.
Okay. So we got some good examples, right? And to be specific, we usually assign motors to drivetrain. So our drivetrain, the drivetrain also has its own motors, right? And the lifter, and like somebody said, also has pneumatics, right? So let's go ahead and think about this then, right? Let's go ahead and think about drivetrain and lifter. Okay. So this is what we're gonna try to focus on right now. And so we separate code into subsystems, which in this case we have two subsystems already defined here, right? Our imaginary robot is definitely going to have a drivetrain, right? Because it has to be able to drive. And depending on the game, it might have a lifter where you have to actuate some pneumatics, right? Like say like lift a box upwards or something with a piston. I'm not sure. That depends on the design of the robot, but basically, instead of dumping all of our code into robot.java, which you could technically do, it would really quickly get clumsy and things would get really disorganized. So the best way to do it is we split the code into subsystem. And the way that 2813 has traditionally done it for several years now is that each subsystem is like its own mini copy of robot.java. Um, After next class or whenever we get everyone caught up, I'm gonna actually make a repository. I'm gonna make a branch, and then I'm gonna that has our in competition libraries and the way that we do subsystems, and then we'll start learning from there. But for now, we're gonna do a really simple form of what we do for subsystems. Okay. So the first thing we're gonna do is just here. Let me see if I can get the screen smaller. Everything should look a bit bigger now, right? Um, on the left side, we're gonna go in and create a new folders. Or basically packages. That's the more accurate term. And go to com.team2813.frc. So this specific package. I'm going to right click this, new package. And then we're going to define this as subsystems. Okay. And Samri and Samir, I'll go ahead and let you guys. Oh, actually, hold on. Before we do that, we're also going to make a new Java class, and we're going to go ahead and define our drivetrain first. So we're just going to call this drive. Okay, and just make a normal class. And then and then we're gonna make another file. It's called lifter, right? And then one last thing is we're gonna go ahead and make a Java class called Subsystem. And we're gonna go ahead and make this an abstract class, okay? So I'm gonna go ahead and let you guys do this right now. If you guys remember correctly, the reason we have an abstract class is because we know that all the subsystems are likely going to follow a similar schematic, aka the code is going to look similar, its function definitions and whatnot. And so we're going to be using an abstract to make sure that all of our subsystems, we only have two right now, but I'm checking the Robot 2020 code. We have like definitely more than two, like perhaps
Wait,
up to
should we
six.
already like extend like the
We
class?
can do it as we go. Let's go ahead and define the abstract class first. So so basically, what we're going to do is we're going to define a few functions. Okay, we're going to keep this really simple for now. We're just going to be we're just going to have two functions. Okay, or two methods. We're going to say public void read periodic outputs. Okay. I believe I can leave this on the here like this. Okay. And then public void write periodic outputs. And then, oh, actually, hold on. I think I screwed this up. Define it like this. So define these as abstract methods. So we have to overwrite this if we decide to extend it. And then one last thing we're going to do is probably, I'm going to refer to this really quickly. Let's see. I'll do, okay, actually, you know what? That's fine. This is fine. We'll start off like this. We'll start off nice and simple. Okay. And so this is going to be a subsystem. So judging by the names, what do you guys think these methods do?
Pretty sure the read periodic outputs will like analyze
sorry.
whatever output the thing is getting. So, like whatever
That's the wrong method. I was thinking read periodic inputs. I think that was another one. But yeah, that reads inputs. Yeah. And this one writes to the output, right? And then we'll put in a few more classes that, so we're gonna put in onDisabled. Notice that I'm not making this abstract because I'm not saying that this is required. Some systems may not have to do this, but in our case, we have a subsystem that we might want to do this. So we're gonna go ahead and put it on onDisabled. Okay. And so basically, I'm just gonna double check, make sure I'm not doing something wrong. Yeah, okay. So now what we're gonna do is we're gonna go ahead, let's go ahead and do drive first, okay? And then we're gonna public class drive extends subsystem. So we're gonna go ahead and extend the abstract class. And you're gonna see that IntelliJ is gonna give us some errors. And then if you hover over it, it will say class drive must be declared abstract or implement the methods. And so when you hover over it, just press implement methods, do all of them, and your error should go away. Okay. So I'm gonna let you guys have time to catch up to where I am right now.
You do it for both classes, lifter and
so this is what you want for both classes eventually. Okay. And for the drive.java, you should be able to use the autofill feature. You shouldn't have to manually type out the methods.
Wait, can you go over again if it's underlined red, not correct for the drive?
Yeah, so take a look at this. So right now you see that it's underlined red, right? If I hover over it with my mouse, this little pop-up will show up and there should be two blue buttons. I just press implement methods.
Okay.
My screen sharing is paused. Okay. So far this kind of system kind of makes sense right now.
yeah.
Okay.
Yeah.
Before we go ahead and start writing stuff in Drive, let's go ahead and make it clear about when read periodic inputs is called, when write periodic outputs is called, and onDisabled and onEnabled. Okay. So for the sake of a Drive system, okay. Samir, what kind of like stuff do we use to drive the robot? Like
the code used?
or like what kind of like physical object? Do we like use a keyboard? Do we use a joystick? Do we use a controller?
A controller?
Right. And how do we get the control? We have to, what do we have to do with the controller in order to like have the robot respond to the to a driver?
We have to pair it to the robot?
Okay, yeah. You have to pair it to the computer, but you also have to read the inputs of the joystick. So we have to figure out when we want to read the joysticks, right? So for now, let's go ahead and assume that we want to read the joystick all the time. Okay, so like even if the robot is disabled, you can move the joystick around and the the driver or the programmer will be able to see when the joystick is the joystick values are changing. So when do you guys think read periodic inputs? So we read joysticks here, right? When do you think we should read joysticks in robot.java? So should we call it in robot periodic? Should we call it in autonomous periodic, teleop periodic? If we want to read joysticks all the time, where do you guys think we should call this method? Does anyone know? Sanri, do you know which method we would call
If you're
joysticks
calling
in?
it all the time, probably robot periodic, right? Because
Yeah,
regardless
that's
of
right. That's right. And then write periodic outputs is when we output stuff to motors. We output motors or pneumatics, right? Let me spell that correctly. So Samir, when do you think write periodic output should be called? Because if you think about it, we don't want to be trying to control the motors or the pneumatics when the robot's supposed to be disabled, right? So when do you think it should be called? Autonomous periodic or teleop periodic or robot periodic?
Autonomous periodic?
Yeah, that's correct. And the other correct answer would also be teleop periodic, because autonomous periodic and teleop periodic are called when the robot is enabled. And the likelihood is you're gonna want to output stuff to motors during autonomous and teleop periodic. So here I'm gonna leave another footnote that says autonomous periodic and teleop periodic. Okay, so I hope this kind of gives you guys an idea of how we how robot.java can control the methods that we do in the subsystem are called differently. Does this make sense to everybody so far? I'm gonna
Yeah.
assume. All right, cool. Right, so let's go ahead and actually write a few code. So how many, okay, I'm just gonna throw up a number, or not throw up a number. How many motors do you guys want for our drivetrain? Should we have 6 wheels or should we have 4 wheels? Or sorry, should we have 6 motors or 4 motors? What do you guys think?
Doesn't West Coast use 4 motors, or does it use 6? At West Coast.
So technically both. It depends on how much power you need.
Whatever. We'll go. Let's do 6.
Okay. So let's go ahead and define our motors then. Okay. So I believe we can. What is it called? Hold on. PWM. Let's just do a PWM. Where's the Sparks? This works. We're gonna call a Spark. And so right now we're defining a few motors within our subsystem. So we're just gonna say, and usually the way that we set up motors in a drivetrain, and this is really important information, is we don't drive 3 motors all at the same time. We initialize a bunch of motors, and then we have the motor follow one another. Okay.
You can't do that with Sparks.
You can't do that with
that's a
Sparks.
Bad choice of.
Yes. Okay.
Um,
I'm trying to use a PWM motor because I'm not sure if the simulator supports.
You don't think the simulator supports CAN?
I don't think so. Oh, you know what? We can do PWM SparkMax, right?
Yeah, or Talon FX.
Let's do Talon FX because Talon FX is the new thing. So we're doing master slave still, right, Grady? We're not changing from that.
Yeah, do leader follower, whatever you do.
Okay.
If it lets you. Which it should.
So let's go ahead and define our master motors first, though. Okay. So you can see here we're defining our motors, and generally, if we're in competition, we're going to be using just Talon FX, which it doesn't exist in WPI though. That's another library you have to download. But for the sake of being compatible with the simulator, we're going to use the PWM. So you might have noticed here that I also gave it actually, I'm not sure. No, let's not make it a constant notation. We're going to go in and define we're going to initiate a new PWM Talon FX object. And basically what this does is let us define a motor that is connected to the robot. And this is something in competition you will communicate with the electrical and the design team to make sure that you guys have the correct ports. and so for that, we're just going to go ahead and pay attention here. So you can see here, PWM talent FX, we're given the channel, which is something that plugs into the RoboRio. And then let's just go ahead and assume that the left motor master is going to be on PWM channel 0. Okay. And we're going to go ahead and define our PWM right motor master. I'm going to define it as 2. Or, no, 3. And then in between, we can define more talents. We can call this slave 1, 2. Okay. And then we just go ahead and copy this over. And we will rename this right. Right. Okay. So let's go ahead and look at this really quickly. So we have 6 different motors attached to 6 different PWM channels. Okay.
I have a question.
Yeah, go ahead.
How did you get the channel things?
Oh, so that's not something you type up. That's something that IntelliJ automatically creates. See, when it's just type 3, channel just pops up. It's IntelliJ's way of notifying you that this is what this parameter means. So it's not something you type up. Don't worry about it. And then in code, we're only going to actually control the left motor master and the right motor master, but the rest are just going to follow. Okay. And let's see really quickly if we can follow. Oh, we can't. Okay. So because we are unable to follow, for the sake of this example, we're going to go ahead and just comma these slaves out. Okay. We're just going to assume that we're going to neuter our robot a bit. We're only going to give it 2 motors. Okay. And then for the sake of also following what we do in competition, we're going to go ahead and make a constructor for drive. Okay. Just like this. And then we're gonna, usually we don't have to do this because these are PWM motors. So I'm just gonna comment it out automatically. But usually you can say right motor slave 1 dot follow. That's usually a method in the full talent FX, the CAN bus version of the FX. And then you can put in your main motor. Okay. So this is very similar code to what you might see in an actual robot, right? You set them up and make sure they start following. See. Okay, does this make sense to everybody so far? The way that these the motors, masters, and slave work? Samri and Samir, you guys are good on this, right?
Yeah.
All right, let's go and continue. So now we're gonna go ahead and set up our joysticks. Okay. So there's another object that the WPI lib provides in this library, and it's called joystick. I'm not sure we can get more simple than that. And basically, they use the name joystick, but it's really because they used to use these. Here, let me see if I can find an example. These are the kind of joysticks that most FRC teams used to use, and most of them today actually still use these joysticks. So that's why it's not called controller or controller, it's called joystick. And the joystick will also define several axes, right? So there's this axis here. This can go from -1 to 1. Obviously, there's the Y and the X of the joystick, and then there's a lot of buttons too. And obviously on modern controllers, we also have 2 joysticks. We have 2 more axes up here for the triggers, and then you got a bunch more buttons too. So basically nowadays a joystick object can have tons of buttons and axes that you had to access. Okay. And for now, you guys can just copy and paste the configuration I have already. But usually the very first joystick you plug into the driver station is going to be on port 0. So we're going to go in and define another member variable called joystick equals new joystick port 0. Okay. And I'm going to make this private. Actually, no, never mind. We can just keep it package private for now. Okay. And then we're going to define a few private variables. Okay. And these are called private, these are called demand variables. Okay. And this is something that we often use in our own FRC robot code. And basically it makes it really simple for the subsystem itself to set the motor speeds, but also if another subsystem has to interact with this subsystem, all they have to do is change the variable. They don't have to directly call the motor. And sometimes this can help prevent like conflicting calls and whatnot, feeling the CAN bus or whatever. And in general, it does clean up the code quite a bit. So we're going to go ahead and say steer demand and throttle demand and slow mode, which is a Boolean. Okay. So this is how we're setting up our joystick. Steer demand is going to be from 0 to -1. Oh, sorry, -1 to 1. Throttle demand is also going to be -1 to 1. And slow mode is going to be true or false. Okay. Does this make sense to everybody?
Yeah.
All right. Yeah, go for it.
You said the get raw access returns a long, but it returns a double.
Did I say long? I thought I said double. Sorry.
And yes, and get raw button returns a Boolean. Okay.
Yep, that's right.
And those are just whatever, if you plugged the controller into a computer or the driver station, it would show certain numbers, port numbers associated with each axis of the end button of the joystick or other controller.
Yep, that's right. All right. So read joystick, read another joystick, and then slow mode, right? And then okay. Let me just make sure that Samri and Samir are caught up. Are you guys able to copy this code yet?
Yeah, I was able to do it.
Yeah, but when I hover over steer demand, it says create local variable.
Oh, did you create these variables that I'm highlighting right now?
Yeah.
Create.
Wait, can you scroll up?
Yeah, these. Make sure that you create these in the class. So these are member variables. All right, now we're gonna go ahead and get into the fun part, which is driving the motors. Okay, and I'm not gonna bother typing this out because this is slightly what complicated. I just decided, oh, can you copy and paste in Zoom? I don't think so. Here, I'm gonna paste this into the Slack thread for today's class. Give me a sec. There we go. So just copy and paste the code I sent into write periodic inputs, write periodic outputs. Hold on, I gotta rename these. Calls. All right, I'm gonna go ahead and replace the code that I sent in Slack. Let's go ahead and go over this code that we just copy pasted in there. So there's a little bit of mathematics involved, but it's not really too complicated. Okay. All right. Sorry. So basically, this modifier variable that I defined here locally is just I multiply it to the -1 to 1 value. And modifier itself is also going to be a 0 to 1 value. And basically, if we ever want to adjust the curve, basically like, I don't know how to describe it. Okay, you know what? I think Desmos might be able to help here. So there are a couple things that we do for control curves. Okay, and this is what I mean by control curve. Okay, here's a normal y equals x line, right? If you just look at the section from, can I limit the domain? Yeah, there we go. If you look at it from 0 to 1, or actually technically speaking, -1, right? This is basically how if the joystick is 50%, the motor is going to go at 50%. If the joystick is at 1, the motor is going to go full send, 100% of its power, right? And the way we can sometimes change it is we can apply use some other functions other than just straight up x to change the curve. And I believe if I shift this, what was it, 1 over pi? No, or do you multiply it by pi? Okay, whatever. You can get a sine curve to fit in this area. For example, x cubed. You can see that If the joystick is at 0.5, the motor is only going to output 1/8. And if we're at 0.8, the motor is going to be at half speed. And obviously full is still 1. Okay. And basically what the modifier method or the modifier variable is to set it up. And this is something we continuously tweak from time to time. And based on how the drivers feel, it's like, oh, this is too sensitive, this is too non-sensitive, et cetera, et cetera, et cetera. It's very minute, but it can change the feeling of the robot when driving in like very different ways. Okay. But anyways, for now, all we're going to use the modifier for is for slow mode. If slow mode is enabled, then obviously the modifier is going to be divided by 2. And then now the modifier is 0.5. If slow mode is on, the throttle that we send to the motors are going to be decreased. Okay. Right now, I don't have the math inside it for steer. But actually, we can go and just put it in right now. We just do this. Okay. All right. So I'm gonna go and just say, yeah, and basically, okay, I'm just gonna comment that out. And basically, this and steer based on different axes. Okay, and then the modifier will let us really easily change. Will let us really easily change the whatchamacalls it. Well, half the speed with slow mode on. Okay. So does this make sense to Samri and Samir? You guys can give yeah. Does this make sense?
Wait, question. Why are we subtracting steer demand? Right? Because like, aren't they like two independent?
So the idea is if we want to turn left, right? So if we turn left, the steer is going to be. Hold on, let me think.
Oh, okay. So like,
Yeah.
the more you want to turn left, the less power you need in order to make like a sharper curve.
Right, exactly. So you change the left and right side speeds in order to make the robot turn, and steer demand will just affect it. So with throttle demand, if you're going half throttle, both motors are going to get 50% speed, and then that's how it's going to turn, or that's how it's just going to move forwards, right? Because both sides are moving at the same speed, the robot just moves forward. But if you make the left side motor run slower and the right side motor run faster, it's going to start veering left, and vice versa for the other way around. We can
the joystick, right, goes from -1 to 1. So like,
exactly
be able to turn.
right.
Okay.
So if we're steering left, if we're steering left, the left side value is going to get smaller, and the right side value is going to get. Wait, am I wrong about this? Okay, maybe it is negative plus. We'll figure it out in VS Code. Okay.
Oh, no. Actually, yeah, right side would have to be more, right? If you're turning left.
Yeah, exactly. Oh, turning left. So yeah, no, it is like this. Okay. Anyways, let's go ahead and run this code. Samri and Samir, do you guys have the code basically matching what I have right now?
Do you still want us to comment out the last 3 lines?
Yeah, screw this. We can just look at the VS Code simulator output.
Okay.
Samir, do you have this right now?
Yeah.
Okay. We're gonna go ahead and migrate over to VS Code. You guys can go ahead and run this in your own time because I'm not sure if you guys have the right controllers or not, but I'll go ahead and just share my VS Code for now. In fact, why not I just share my whole screen? That might just be easier. Okay. Or I'll share VS Code for now because VS Code is small. Okay. So I'm gonna go ahead and really quickly. Okay, so I'm not gonna change any of the files in here. Okay, that's the job of VS Code. And we're gonna go ahead and run. What is it doing? Okay, I'm gonna go ahead and run this code in the simulation now. All right, we're gonna go into see it in action. So again, top right, we're gonna press the WPILib button. I'm gonna press simulate robot code on desktop. Right, just terminate task. Screw that. Simulate robot code. All right, it's gonna go ahead and run a Gradle build. And then what you're gonna see is I can pull up a few windows in the FRC simulator or the WPILib simulator, and I can see the joystick values change. I can see the PWM value outputs change as well. And obviously we can get the console, right? I'm gonna run HalSim GUI. Okay, I'm gonna change my share screen. Okay, can you guys see my robot simulator GUI?
Yeah.
Right, so I'm gonna go ahead and take you guys can't see it because it's off the camera, but I'm gonna go ahead and plug in my controller. Let's take this. And right now, here, do you see this joysticks box that I'm wiggling? Right now, this says all 5 joysticks are unassigned, right? If I plug one in, come on, please recognize.
You got it over on the
Oh, there it
left.
goes. Yeah, system joysticks.
You
Drag
have a
and drop.
Stadia?
Yeah, this is a Stadia controller. Anyways, let's see. So you can see when I'm like clicking buttons and stuff, you can see that it's like flashing yellow. That just means like we can read it. Why does it say joysticks are unassigned?
I think you're supposed to drag and drop to joysticks. What does that mean?
Oh yeah, you're right. Sorry, drag and drop joysticks. There you go. All right. So you can see. Oh, sorry, my water. You can see here that as I'm moving the controller, the axis numbers are changing, right? And
What
for
about
some
any
reason,
button?
these triggers are buttons, but I can ignore that for now.
Okay.
Right? And if you remember correctly, I bind in axis 0 to steer. If I push it to the left, if I push the joystick to the left, you can see it's -1. If I push it to the right, it's 1. And on the right joystick, you can see going forwards is -1, backwards is 1. And I'm using axis 4 right now. So right now the behavior is as expected for this controller specifically. Now, if I use an Xbox controller, that's going to be slightly different. So usually you're just going to use one controller and you stick with it. Okay. But basically, on the driver station, there's a way to see this as well. This is how you probably get the axis numbers. Okay, right, Grady?
Yes.
Okay, cool. Let's go ahead and enable it. Okay, you can see here. Why does it say no tele-op outputs? Okay, this is the part where you debug code. So let's go ahead and go back in IntelliJ. So right now, our issue is we don't have any PWM outputs. Am I even pushing the right code? That's a good question. Ah, I'm not. Oh, right. There was one critical thing I forgot in IntelliJ. Right. Okay. Hold on. I have to drag my subsystems back in. I never noticed I was still out here. All right. Remember in Subsystem, the abstract, how we said, okay, we're going to read periodic inputs in robot periodic, and we're going to call write periodic outputs in autonomous periodic and tele-op periodic. Remember that, guys?
Right.
So what we're going to go ahead and do is we're going to go ahead and implement that now. So let's go split vertically. Just keep this here as like a note. Okay. We're going to go to robot.java. And then at the top, we're going to go ahead and make our instances. Okay. So we're going to make a variable of type drive. We're just going to call this drive for now. And you can see it's going to ask for me to import. So I'm just going to hover over it, import class, and I can say new drive, right? And then in robot periodic, I can go and say drive dot, and I said here that robot we should call read periodic inputs. So read
Wait,
periodic
Samuel,
inputs.
our subsystem package should be in the FRC package.
Yeah, that's right.
Oh. Okay.
And then autonomous periodic. I'm gonna okay, I'll just put in here. Whatever. Drive dot write periodic outputs, and then in tele-op periodic, drive dot write periodic outputs. Okay. So go ahead and put drive dot write periodic outputs in tele-op periodic and autonomous periodic, and then in robot periodic, put in drive dot read periodic inputs.
Above the switch.
Anywhere, to be honest, I don't care.
Okay.
Samir, do you follow?
Yeah.
Okay. I didn't start the recording. Oh. Anyways, throttle, left, right. Yeah, good stuff. Okay.